So, hello everyone again. This is lecture number 2 from the chapter System of Particles and Rotational Motion. In the previous part, which was lecture number 1, we just started with the lecture, understood a few topics such as translation motion, rotational motion, translation motion plus rotational motion, and so on, and started with the basic definition of center of mass. Let's go with further discussions regarding that topic and understand center of mass in more detail. So this is lecture number 2 from the chapter System of Particles and Rotational Motion. I am Samir Lawankar. Let's begin our discussion. So currently we are on the second topic, that is center of mass. First topic is being completed, which was based upon generally your translation motion, rotational motion, and translation motion plus rotational motion. Right. So let's start the discussion directly from the thing which we left in the previous one. So we finally found that what was center of mass was basically equal to m1x1 plus m2x2 plus dot 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 till mn xn upon m1 plus m2 plus dot 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 till mn, which in summation form can be written as equal to summation mixi upon summation of m. Right. Moving on, so we also understood that summation mi is nothing but equal to m. And in 2 dimensions, let us say we make it in 2 dimensions like this. Let us take this m1, m2, m3, m4 as 4 particles. Then what we can write? We can write basically that the center of mass of these 2 dimensions is basically equal to summation mixi upon summation mi, which can also be written as summation xi upon m. Similarly, for y, we can also write it as summation miyi upon capital. Okay, fine. So that thing being said, now let us go with the further discussions regarding this topic only. Okay, so now so the center of mass similarly, so let us understand now for the z3 axis now, center of mass for 3 dimensions. Okay, so let us assume that there are n particles available on a 3 dimension, right? And we need to calculate its center of mass. Okay, the center of mass of such a system. So center of mass of such a system can be denoted as capital X, which is equal to summation mi xi upon capital M. Capital Y is equal to summation mi yi upon capital M, and capital Z is equal to summation mi zi upon capital M. Okay, so I hope this definition is clear to you, how we got to this point, right? So now let us understand. So this was the basic usage as we applied 1 dimension, 2 dimension, and 2 dimension, 3 dimension. Okay, so with that being said, now let us understand the same concept of center of mass in terms of your position vector. Okay, so using these equations, which is capital X, capital Y, capital Z, we just calculated, right? Let us write some position vector r for the same and position vector r for your center of mass. Just a quick revision. What is position vector? So position vector, let's say I explain this for your xy plane. Let us assume this is your x-axis, this is your y-axis, and let us say that there was some point P which was having dimensions x and y. Okay, then the position vector is basically a vector drawn from the origin or the reference axis to the particular particle is called a position vector denoted by r. If I need to resolve the components of this vector r, what will I get? I will get r is basically equal to some I cap plus some j cap. What is I cap here? It will be x. What will be y cap here? It will be y. Okay. So now let us assume. So first there for 3 axes. So let position vector ri be the position vector. So let ri be the position vector of the ith particle and let r be the capital R be the position vector of center of mass. So what we can write? Mathematically we can write small ri is nothing but equal to some value of xi I cap plus some value of yi j cap plus some value of zi k cap. right? Similarly, capital R can be written as equal to capital X I cap plus capital Y j cap plus capital Z k cap. Okay, I hope it is clear till this now. Therefore, now we can write that this capital R is nothing but equal to summation MI upon capital M. Right? So in the vector form, we can write it like this, right? Because we know. So just using this implementation. So there is nothing new here. Just this implementation is being written in the vector form. Okay. So if you just segregate into different vectors, let's say I did segregate it for X vector, I'll get summation MI xi upon capital M. For Y vector, I will get summation MI yi upon capital M. And for Z, I am getting summation MI zi upon capital M. Therefore, in vector formation, I can write this capital R is basically equal to, so this is basically a vector, no? So this will be in bold letters, and this will also be in bold letters. Okay, this is also in bold letters, and this is also in bold letters. Fine. So that's how we understood. So therefore, this sum on the right is basically a vector sum. This is basically a vector sum being implemented. Above one is your vector sum. Okay, here. So we understood in this point. So rigid bodies. Okay, now let us understand one more thing regarding these vectors. Okay, so finally, what was the implementation we got? The final implementation which we got was summation MI RI upon capital M is equal to R. Okay, now let us assume that how do I explain it? Let us assume that there was a log of stick here. Okay, and I assume the origin to go from this place, right? So there will be many system of particles in this direction, correct? Let us say this process are nothing but system of particles. Majority particles are here, and similarly there will be some particles in this direction also. Okay, so just see clearly, for every particle which is on this direction will also have the same displacement in this direction. And if I simply do m1x1 minus m1x1, I will get the answer as 0. Right? So for each of the particles which are present here, there will be similar value of m1x1 which will be present on this direction. So what we can say that for this case, summation MI RI is equal to 0. Okay. So basically, if the origin of the frame of reference is chosen to be the center of mass, then summation MI/RI is 0 for the given system of particles. Let me just write it here also, the thing which I just said. So if the origin of frame of reference is chosen to be the center of mass, then summation MI/RI will be equal to 0, right? For the given system of particles. Okay, so I hope this line is clear to you. So we just took an example of a meter stick here, basically what we can say, a stick here or a rod here. So a rigid body such as a meter stick or a flywheel is a simple example of closely packed particles, right? And therefore all these equations for summation X, capital Y, capital Z we obtained are applicable to the rigid bodies, right? But now let us understand one more concept. Okay, is there a okay? So let us understand this in this fashion. Every time we cannot keep on summing these very small pointed particles. If we take some particle in this sequence, so that thing is only implemented here. I would start from this location only. So the number of particles or atoms in such a body as in, let us take this wheel, or let us take this as mass. Okay, so amount of small particles to be added would take a large time to get the center of mass. Okay, and that is why we need to obtain, or we need to find a differential form of this equation to move forward. So I hope you understand why we are doing this, because the amount of particles which are being present in this 1 meter of rod is very, very high. So adding all these point masses again and again will take time, cumbersome. If we are understanding this complete concept as differential calculus, it will be much easier to implement. Right? The number of particles, atoms or molecules in such a body is so large that it is impossible to carry out the summations over individual particles in this equation. Since the spacing of the particles is small, we can treat the body as a continuous distribution of mass. I hope you understood this. That if the spacing of this particle, so because if you see clearly, the spacing of each of these particles is very, very small. Okay, so we can treat the body as a continuous distribution of mass. Therefore, what we basically do, we divide these sub body into n element, n small elements of mass, namely delta m1, delta m2, delta mn. The ith element is delta mi is taken to be located about the point xi, yi, zi. The coordinates of the center of mass are approximately given by what? So we can write this as equal to capital X, which is nothing but equal to, just in the place of m, I am writing delta m. Okay, so nothing but delta mi xi upon summation delta mi. Similarly, what will be y? Y will be equal to summation delta my, delta mi yi upon summation delta mi. And what is z? Z is basically summation delta mi zi upon summation delta zi. Okay, so how we got this? Now what we can say, what we can do basically, let us try to increase and increase this value of n. So as the value of, let me write it here so that it is much more clearer. So as n keeps on increasing, delta m keeps on decreasing. Okay, so as it keeps on decreasing, what we can say that these expressions can be converted directly into differentials, and therefore this summations can transform into integrals, right? So then what will happen? What will happen basically, in the place of mi, we can, this is delta mi can be done as equal to dm correctly. So therefore this sort of equations can be converted into these equations. So this is the equation I'm talking about. So these equations can be converted into the following form. What is this form basically? We can just write what is the center of mass capital X. It is nothing but equal to 1 by m xdm. Okay. So I hope this concept is clear to you. So basically, if we basically do the integration of xdm upon m, we will get the answer of capital X. Similarly, what will be capital Y? It's again 1 by m integration by dm. And what is capital Z? It is 1 by m integral zt. Right? This is the final formulation of the thing which I suggest to remember. Please, there is okay if you don't remember the previous formulas, but I would highly suggest if you remember this formula, because questions can directly be framed in terms of this formula. Okay. On similar terms, what if we need to write it as vector notation or vector form? So in vector form, what we can write? We can write basically this capital R is nothing but equal to 1 by m integration RD. Here this R is also in capital formulation and this small r is also in capital formulation. Okay, so I hope you understood the complete concept of calculation of your center of mass. Okay, now just a simple case understanding here. If we choose some small r is 0, then this capital R is equal to 0. Okay, so often we need to calculate, we have to calculate the center of masses of homogeneous bodies of regular shape such as rings, discs, spheres, rods, etc. So by using symmetry consideration, we can directly say that the center of these bodies lie at the geometric centers. The thing which I'm just explaining you is this, that so for each of this, what we can say that the amount of mass which is in this direction is equal to the amount of mass which is in this direction. Hence we can say that the center of mass of all these, okay, this is in center only, sorry for such a little difference here. So it's a sphere, okay. Everything will lie in the at their geometric centers. Why? Because the amount which is in this direction is same as in this direction. That's why. So it can be understood for a rod. This is your disc. This is your ring. And this is your sphere. Fine. So that is how you can understand this complete concept. Okay. So that thing being said, just a simple explanation which we have just involved here. So let us consider a thin rod whose width and breadth uh, is in the case if it is a rectangular, then it is the cross section is rectangular, and if it is cylinder, then it can be understood as a radius, right? Which is much smaller than its length. Now let us take the origin to be at some geometric center. Let us take this to be the origin O. Okay, so let us take the origin to be at the geometric center of the rod and x-axis to be along the length of the rod. So we're taking the x-axis along the length of the rod. We can say that on account of reflection symmetry. So taking the origin to be at the geometric center of the rod and x-axis to be along the length of the rod, we can say that on account of reflection symmetry as in if we put a mirror in this location and find a symmetry of this, we will find the same dimension here. That is the basic meaning of reflection symmetry here. So on account of reflection symmetry, for every element dm of the rod at x, for every element dm on the rod at x, there is an element of the same mass dm. There is an element of the same mass dm located at minus x. Okay, so I hope this line is clear to you. Right. So the net contribution of each such pair to the integral, and hence the integral xdm itself is 0. So you know what is the integral basically? It is nothing but x dm upon capital M. So there would be something with plus xdm, there would be something with minus xdm, and hence the complete summation will give you the value as equal to 0. The point for which the integral itself is 0 is the center of mass. Hence, this is that point which is nothing but your center of mass. Thus, the center of mass of a homogeneous thin rod coincides with its geometric center. Homogeneous, what is the meaning of homogeneous? That means at any location, if you calculate the value of dm, you will always find its value to be constant. And thin rod as in, it is having very, very small value of thickness. Okay. So it coincides with the geometric center. This can also be understood on the basis of reflection symmetry. Okay, so that is the amount which is in x direction, is the same which is in the opposite direction. Okay. The same symmetry argument will apply to homogeneous rings also. So this is the only explanation which I already did. It is just written here. The same symmetry argument will apply to homogeneous rings also. So ring, what is a ring? The ring is basically all the mass is being kept at some distance r from the center. Okay, so we'll apply to homogeneous rings. That can also apply to discs. Okay, that can also apply to spheres. This is basically a 3D surface. This is your 2D. This is your 3D. Or even thick rods of circular or rectangular cross section. So basically thick rods as in this. Okay, for thick rods also, the center of mass will lie at its geometric center only. Right? For all such bodies, you will realize that for every element dm, at a point xyz, one can always take an element of the same mass at the point minus x minus y minus. So I hope this line is clear to you. In other words, the origin is a point of. So in other words, what is origin? Origin is basically a point of reflection symmetry. So reflection symmetry is being obtained. Here also reflection symmetry is being obtained. Here also reflection symmetry is being obtained. This means that for all the above bodies, their center of mass coincides with their geometric centers. Okay, so that is the final conclusion. That for all these bodies, such as ring, then your cylinder, basically a rod, thick rod, basically discs, spheres, etc. The center of mass coincides with the geometric center. Fine. That thing being said, now let us try to solve one of the questions regarding the center of mass. Simple question, simple. So what is the final conclusion? What is mathematical final conclusion we obtain? The mathematical final conclusion is for every mass, we will get some x, we'll get some y, we'll get some z. What are those values basically? It is nothing but in summation form, it is nothing but summation mixi upon capital M, summation miyi upon capital M, summation mizi upon capital M. Okay, but in differential form, this will be equal to 1 by m integral x dm, 1 by m integral y dm, 1 by m integral z. Okay, so that being said, now let us understand the complete discussion which is being asked. Okay, so the question says that find the center of mass of three particles. So we can directly use the summation concept here because the number of particles are not very large. At the vertices of an equilateral triangle. So there is some mass here, there is some mass here, and there is some mass here. Okay. The masses of the particles are 100 grams, 150 grams, and 200 grams respectively. Each side of the triangle is 0.5 meters. Okay, fine. Let us understand. So what we basically do, as this is an XY plane concept only, so you just need to calculate capital X, which will be nothing but equal to summation mi xi upon capital M. First, let us calculate this only. There is nothing but equal to, let us take this as mass m1, this as mass m2, and this as mass m3. Okay, so it's m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. And because we know what is capital M is nothing but summation m. Fine. Now let us solve. What is m1? It's 100 multiplied by some value of x1 plus m2. What is m2? It's 200 multiplied by some value of x2 plus m3. What is m3? It's 150 multiplied by some value of x3 upon 100 plus 200 plus 150. Fine. Now let us calculate the value of x1, x2 and x3. So what is x1 here? X1, basically this mass is at origin, therefore x1 will be 0. What will be x2? So x2 can be seen clearly as this is 0.5, as this is 0.5, right? Okay, see from this half circle, half triangle. Okay, let us so this side is given to you as 0.5 and this angle is given to you as 60 degrees, correct? Now let us assume this to be your base and this to be your height. Okay, therefore here this base will be equal to nothing but 0.5 cos 60 and this will be equal to 0.5 sin 60. Okay, I applied simple trigonometry here. Therefore this base will be equal to 0.5 by 2, which will be 0.25, and this will be 0.5 into root 3 by 2. So it will be root 3 by 4. Okay, so I hope you understood how we understood this concept or these values. Okay, so basically it's 0.5 into root 3 by 2 for this case scenario, and it's 0.5 into 1 by 2 for this case scenario. Right, so 1 by 2 into 1 by 2 will give you 1 by 4, and root 3 by 2 into 1 by 2 will give you root 3 by 4. That's how we obtain these values. Okay, so hence what will be x2 value? X2 value will be nothing but equal to 0.25, correct? Okay. Similar sense, what will be x3? X3 will be nothing but equal to this complete distance, which is equal to 0.5. Okay. So you know this value, you know this value, you know this value. Just put the results. After putting the values, you will get the value of x as nothing but equal to 5 by 18 meters. Okay. I hope you understood how we got the value of capital X, which was 5 by 18 meters. Okay. So let me just add one more. Let me just add one more page here so that I can do the same thing for your y-axis. Okay. So okay, fine. So here what we will do, we will calculate the value of capital Y. What is capital Y? Basically, it's summation mi upon summation capital M. Right. So it is equal to m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Okay, so therefore what we can write? We can write this is equal to 100 into y1 plus 150 into y2 plus 200 into y3 upon 100 plus 150 plus 200. Right? So let us calculate the value of y1. What is y1 here? As you can see, y1 is 0. What is y2 here? Y2 we just calculated right now. That is nothing but equal to root 3 by 4. What is root 3 by 4? And what is y3 here? Y3 here is basically y3 here is basically again 0. Okay, so put the values of y1, y2 and y3. So therefore finally we will get the value of capital Y as nothing but 1 upon 3 root 3 meters. Okay, so what is the final answer? Final answer is basically that capital X is nothing but equal to 5 by 18 meters and capital Y is nothing but equal to 1 by 3 root 3 meters. Okay, that is the final conclusion of this complete question. Fine. Let us understand the second question now. The question asks is you need to find the center of mass of a triangular lamina. Lamina as in some figure which has been drawn on a plane. Okay, so let us understand this diagram. So the question is simply that find the center of mass of a triangular lamina. Okay, so to calculate this, the lamina, that is delta LMN may be subdivided into narrow strips, each parallel to the base. So basically you are dividing it into this form here like this. Okay, so these are basically very, very narrow strips being understood or explained here. By symmetry, each strip has its center of mass at its midpoint, because now what will happen, this won't be of this sense, right? When it is very narrow, it will be almost a rectangle only. So therefore, where will the center of mass lie? It will lie exactly at the center. By symmetry, each strip has its center of mass at its midpoint. If we join the midpoint of all the strips, we get the median LP. I think it's clear to you. The center of mass of the triangle as a whole, therefore, has to lie on this median LP. So it would lie somewhere in here only, because we know that it is symmetrical. Correct? So similarly, we can argue that it lies on median MQ also. So now let us say that we have subdivided that scenarios in this form. So therefore, a triangle, the center of mass would lie somewhere in this location. Also, we can also say similarly of this fashion that the triangle has been divided in this form. And in this form, what we can say that the median or basically the center of mass will lie in this direction. But to satisfy all the three criteria, there is only a single point which intersects all these three lines. Okay, so what does it basically mean? It basically means that the center of mass lies on the point of concurrence of the medians. That is on the centroid G of the triangle. Okay, I hope this concept is clear to you. How we got to know that why this value of your center of mass basically is lying on the concurrence of the three different values of medians. Okay, right. So that thing being said, now let us move forward. Another example. Now this example is based upon, and so these are nothing but different ways in which the questions are being asked regarding center of mass. Okay, so let's look at the question. So find the center of mass of a uniform L-shaped lamina. So this is the L-shaped lamina been explained here. Okay, so the dimensions as shown. So the mass of the lamina is 3 kg. Now look at this diagram very clearly. Okay. Let us assume that I divided this complete lamina into 3 different areas. The first is this area, second is this area, and third is this area. Right? Therefore, as it is divided into 3 equal parts of square, what we can say that each of this is having same mass, which is 1 kg. Okay, so if by any way or sense I can calculate the value of next thing is what will be the center of mass of 1 minute. What will be center of mass of all of this? As it is geometrically square, the center of mass will lie at geometric center. Here also to lie at geometric center. Here also to lie at geometric center. Okay. Now, if I assume these three to be extended bodies and solve the concept of center of mass, then also my answer should come as correct. Okay. So let us understand that fashion only and let us try to calculate the answer. Okay. Fine. So as the center of mass is being asked, what will I basically do? Let us first calculate capital X. What will be capital X? It is nothing but equal to your m1x1 plus m2x2 plus m3x3 upon m1 plus m2 plus m3. Quite clear? M1, M2, M3 are both or 1 or all are 1. We can directly change it into x1 plus x2 plus x3 by 3. Now see the diagram very clearly. What is the value of x1? The value of x1 will be 1 by 2. Why? Because the complete is 1 till here, hence half of that will be 1 by 2. So it's 1 by 2 plus x2 will be this 1 plus this 1 by 2. So what will be 3 by 2? That is 3 by 2. Similarly, what will be x3 here? X3 here will be again 1 by 2 only. Okay. So on solving this, you will find the answer as nothing but equal to 5 by 6 meters. Fine. Let's move forward. Calculate y also. So what is y? Simply m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Right? So as we know that masses m1, m2, m3 are both all same, which is equal to 1. So we can change this equation into y1 plus y2 plus y3 by 3. Okay? Which is equal to nothing but, what is the value of y1 in this sense? It's 1 by 2. y2 in this sense, it's 1 by 2. y3 in this sense will be equal to 1 plus 1 by 2, because 1 it is in this form and this is nothing but 1 by 2. It's 3 by 2 divided by 3. So therefore this will be again 5 by 6 meters only. Okay. I hope you understood how we obtained the values of center of mass for this. Okay. So what is the final answer? X is equal to 5 by 6 meters and y is also equal to 5 by 6 meters. Okay. Fine. Let's move on. Okay, so that thing being said, let us now solve one more example. So this is a JE problem which was asked in one of the previous years. Okay, it's based upon your center of mass concept only. First of all, let's look at the question and let's try to understand. Okay, so it's a simple question only. So the question simply states that a circular plate of uniform thickness. So it's a circular plate of uniform thickness has a diameter of 56 centimeters. So diameter is given to you as 56 centimeters. Okay. And a circular portion of diameter 42 centimeters is removed from one edge of the plate. So some sort of this is happening. Okay. The diameter of this small circle is given to you as 42 centimeters. Okay. So as shown in the figure, the question asks is simply that you need to find the position of the center of mass of the remaining portion. You just need to calculate the center of mass of this portion. Okay, so I hope the question is clear to you. Now just look at the formulation which I'm trying to do here. Okay, so for the questions involving decrease in the center of mass or area decrease in the center of mass, this has to be implemented. So basically what we can understand it like this, it is nothing but equal to, so in one way what we can say that it is nothing but an addition of a negative area. An addition of a negative area is being implemented. So what we can say, the center of mass can also be located as M1A1 also. So we can write it as M1A1 plus M2A2 like this also. Okay. So when we are implementing it in this fashion, we can write this as equal to capital X, which is equal to M1A1 minus M2A2 upon M1 minus M2. Okay. What is M1 here? M1 here will be nothing but So basically here what we will do, we basically assume that the amount of mass density. So M1 and M2 will be same here because we are assuming here that the mass density is same, right? For thickness, for circular bed thickness, mass density is same. So this will directly change to the formation of. So what is A1 here? A1 is basically pi by 4 into 56 squared, and A2 is nothing but equal to pi by 4 into your 42 square. Okay, so therefore we can directly write this value of center of mass is nothing but equal to pi by 4 56 squared, correct, minus pi by 4 into 42 squared upon pi by 4 into 56 squared plus pi by 4 into 42 square. Okay, so when you will do the implementation here, finally you will get the answer is nothing but equal to 9 centimeters. Okay, right. So basically what is happening, the center of mass of the system is being shifted towards the left hand side. Okay, so that's how this question is being implemented. Right. So that thing being said, we have completed the discussion of the center of mass of the system, center of mass of understanding the center of mass in the vector formulation also, and in the what we can say in the normal formulation also. Also, we understood the differential form of it, that is basically integration xdm upon m, integration ydm upon m, integration zdm upon m, and so on. Right. So that thing being implemented, now let us understand the motion of center of mass. Okay, so now let us understand what is the kinematics involved, how we understand this complete kinematics, and then move forward. Okay, let us understand a new subtopic, which is basically called as your motion of center of mass. Okay, so this will only involve all the mathematical calculations only. So we are just trying to broaden our aspects from the movement from position to velocity to acceleration and so on. Okay, so let me start the discussion. Let me start writing and just understand whatever is written. Okay. So equal to the definition of the center of mass, we are now in a position to discuss its physical importance of a system of particles. So we understood the basic meaning of center of mass. Now let us understand its significance. Okay. So as we know that capital R is nothing but equal to summation mi ri upon capital M. So this can also be written as M capital R is nothing but equal to M1 R1 plus M2 R2 plus dot till Mn Rn. Correct? So there is no issue in writing this. Now let us differentiate both sides of the equation with respect to t. So how we will write this? As m is a constant, it can directly go out. So it's nothing but m dr by dt is equal to m1 dr1 by dt plus m2 dr2 by dt plus mn drn by dt. Correct? Now we simply know that dr by dt is nothing but velocity. Therefore, what we can write? We can write directly m into v. V is basically our capital V here, or we can say the velocity of the center of mass. Okay, this is equal to m1 v1 plus m2 v2 till mn. Okay, so this is the first formulation we got, that the center of mass or the momentum of the center of mass is equal to momentum summation of the momentum of the system of particles. Okay, fine. So this was the first differentiation being done. Let us differentiate this again. So differentiating both sides. This time again, mass is kept as constant. So what we can say? We can directly say that m dv by dt is nothing but equal to m1 dv1 by dt plus m2 dv2 by dt plus m3 dv3 by dt. Correct? What is basically dv by dt? We know that dv by dt is nothing but equal to acceleration. Therefore, what we can say, mass into acceleration is nothing but equal to m1a1 plus m2a2 mna. Okay. So I hope this concept is clear to you, that the acceleration of the center of mass is equal to summation of the, basically the force exerted on the center of mass is equal to summation of the all forces exerted on on the system of particles. Right? So basically, as we know, as F is nothing but equal to m into a, therefore we can write m capital A is nothing but equal to F1 plus F2 till Fn. Correct? So thus we can write, so let me write that line directly here. So thus the total mass of a system of particles times the acceleration of its center of mass. So mass into acceleration is basically equal to the vector sum of all the forces acting on the system of particles. Fine. So that was the complete final conclusion which we occurred here, that the total mass of a system of particles times the acceleration of its center of mass is equal to the vector sum of all the forces acting on the system of particles. Okay. Fine. So that thing being said, now let us move forward and understand something which is basically, so this is the thing which is written here only. So the thing which I just wrote is written here. Fine. Now let us talk more about the force here. Okay. So here the force which is being talked about, let's say F1, is basically made of two different forces. Okay. So let us take, so basically what we are basically doing here, it's nothing but m into capital A, which is equal to F1 plus F2 plus F3 and so on till Fn, right? So what is this F1 here basically? This F1 is total forces acting on particle 1, correct? It is not a single force acting on particle 1, it is the sum of all the forces acting on particle 1, correct? Okay. So now a new concept to be explained to you. Basically, there are two types of forces. One is your internal forces and one is your external forces. As the name suggests, internal forces keeps on happening in the internal of the body with the different particles, and external forces are being due to the external agencies being employed, such as gravity, etc. Okay, so among these forces on each particle, there will be some external forces exerted by bodies outside the system, and also internal forces exerted by the particles on one another. Okay, now using the Newton's third law of motion. So now using the Newton's third law of motion, basically what we say that the internal this internal forces occur in equal and opposite ways, and therefore the sum of the forces due to their contribution is zero. Okay, so I will try to prove you why we say that the summation of internal forces is equal to zero. Right now, you just understand this because only 2-3 minutes are left. I will try to close this concept here. So finally, what is the final conclusion? The final conclusion is simply that mass times acceleration is equal to F external. That is the summation of the force external exerted on all these complete different particles. Okay. So that thing being said, let me stop the discussion here. So currently we have completed with the introduction, the center of mass, and we are currently in the third subtopic, that is motion of center of mass. Fine. So let me stop it here. We will continue with the discussion here on the next part of the lecture. So thank you so much.